Right, hello there ladies and gents, welcome to another repair video. Today we're going to be taking a look at this Nintendo Switch which has been sent in. This particular console has been sent in because it has a damaged USB-C port, and it also says on the ticket a serious error when tested with a charged battery. So I'm going to go out and hazard a guess and say that we're getting the 2101-0001 error, which is pretty common when we have a damaged USB-C port. We get some collateral damage on the M92T36 chip, and that causes the error in question. So I haven't actually seen the error yet because obviously, you know, it's got a dead battery and things like that. But I'm going to try it with an on-good battery. I'll see if it replicates that error for me, and then we'll see what we can do about getting it fixed. So I can't actually show you the port because it won't show up on the camera, but I will be able to show you once we get under the microscope with it that it is indeed damaged. I can see it myself, but it just doesn't show up on camera. I just can't get the correct lighting to be able to show it up. So, but there is indeed about 8 or 9 pins which are out of position and things. So the error code could be coming up just because those pins are touching, and then once we relieve that short by lifting the port off, that could indeed relieve that error code. But 9 times out of 10, it's going to be something to do with the M92T36 power management IC. So let's take it apart. Let's put a non-good battery in it, which we know is charged. Let's turn it on, and we'll see if that error replicates. And then we'll also see if that error goes away once we've lifted the broken port off. So while I've got your attention, if you do like this type of content and you want to see more, be sure to hit the subscribe button down below and turn on the bell notifications so that you're notified every time that I upload. Okay, so now that we're inside, what I want to do is I just want to test it with another battery just to make 100% sure that we're getting that error code. And based on the error code, is going to determine what's actually wrong with this. Now, the board's going to have to come out anyway, but I just want to see that error code and verify it on screen for you guys, just so you can see what's actually going on with it. I'm going to pop in a battery there, and let's turn her on. Not sure if there's any battery power in this. No, that one's dead. Typical. Never mind. I do have another one that should have a little bit of power in it. I do need to charge these up. It's getting to that point where they are running dead. It takes about 5% of charge every time I use this to turn a battery on, to turn a console on. Between 3 and 5% generally. I do have another one just there though. Okay. Oh, there we go. Okay, yep. So error 2101-0001. So if we take a look at that there, you can see that we've got the 2101 error code, which is kind of what I expected. That's generally a power management issue error code, and it's a hardware failure error code. So there's not a lot of information online apart from the stuff that I've published on my YouTube channel. Not many people know what the error means exactly. And not many people have pinpointed the exact root cause of the error code. I don't think it was until I actually posted a video on it that it actually got started, that people started mentioning it more, which is kind of strange because obviously, you know, these consoles are fairly old now, and you would have thought that it would have been documented a little bit better before, but no, apparently not. Alright, and board is now out of the console, so what I'm going to do first is just clean off the thermal paste that's on the heatsink here, or rather on the CPU shield, CPU and RAM shield. The reason I clean that off now is because I'm going to be replacing it before it goes back together anyway, and I don't want it all over my hands, so yeah, there is that. Okie doke. There we go. Right, so let's put this under the microscope, and I'll see if I can show you the board itself, or rather the port itself, and just see if we can see exactly what's happening with it. So I'll just get the microscope set up. Okay, so taking a closer look at the port, then you can clearly see that that is very badly damaged, and that is definitely going to need to be changed. So we can see one pin is definitely touching the chassis, And then there's ground touching one of the data lines on the left hand side there as well. So the end pin is touching the one next to it. That side's fine, but that's going to be the cause of the error code for sure. Now, whether or not that's actually blowing M92 is hard to say. We need to remove the port first, and then we can check for shorts around M92. So let's get this port off, and then we'll check for shorts. We'll see what kind of issues we're facing, and then we'll see what we can do about actually fixing it, shall we? Alright, so to remove the port, what I'm going to do is I'm going to put the hot air station on to 480 degrees Celsius and 50% airflow, and I'm just going to heat up the general area first, and then I'm just going to focus the heat directly on the USB-C port itself. I'm not going to use any kind of low melt on this. I don't feel like it's necessary. A lot of people do like to use low melt, but I think it's just a waste of time. The board is thin enough and it doesn't need low melt solder if you do it properly, and I'm going to show you how to do it properly now. So if we just heat up the general area here, you can see that I'm just coming round and round in a circle with the hot air. I'm not directly on top of the port. I'm just going to put some general heat in the area. Once the board has warmed up a little bit, it's a little bit hot to the touch, I'm going to focus directly on the port itself. And every few seconds, what I'm going to do is I'm just going to come in with the tweezers. And I'm just going to tap the port just to see if it's ready to lift up. And you can see that there where that port just moved. I'm not going to touch it yet. I'm going to give it another 10 seconds or so, and then once I'm comfortable that it's had more than enough time to melt the solder, only then will I lift that port off. And as you can see by that, there are no torn traces, there's no damage to the board, and we didn't need low melt solder. So that was a perfectly clean removal of the port, and all you need to do is literally just wait. That is it. Just wait, and you don't need low melt solder. You don't need any special tools. You don't need any special equipment. Just patience. Just leave it for probably, I don't know, a minute, and you know for a fact that the solder is going to be melted. It's a very thin board. It doesn't take much at all to remove it. With the port off, now I can focus my attention on the power management IC, which is this IC here, M92T36. So this, like I said, is a USB-C power management IC, and this controls all power going into the board. So when it comes from the USB-C port down here, you'll see that all of these traces lead up to here. So you follow them along all the way to the top, and you come to this chip here, and everything comes through this chip first. So this is always the most common chip to blow, and it's not a defect with the chip, it's just the fact that people break the ports and things like that, and that's what causes the chips to go bad. So when we get a broken port, or when we get a short on the port, or a power surge or something like that, it travels through to here and causes it to blow. Now there is a fuse just down here, and this is supposed to be a quick blow fuse. However, the problem with that is if you get a short on the data line, which is what appears to have happened here, then it travels completely past the fuse, because there's no fuse on the data line. It travels completely past the fuse and it goes straight up to M92, and bang, there you go. That's what happens. So like I said, it's not a defect with the chip, it is just purely a case of bad luck on the user's part. So what I'm going to do now is I'm going to pop the multimeter onto continuity mode. So continuity mode is the mode that's going to beep when we complete the circuit, and what this is going to tell us is whether or not we have continuity between one point and another. So for example, when I touch the probes together, we hear a beep because there's continuity from one probe to the other. And the reason that we're going to be using continuity mode is because we want to listen for an audible beep if we have a direct short to ground on any of the components around M92. So what we can do is we can figure out which side is the ground side and which side is the input side of these capacitors. And I already know that these input sides are on the bottom for these ones, and it's on the right hand side for this. and then so on and so forth. But I'm going to say, based on the fact that we have a little bit of discoloration here, we may well have a short on this capacitor just here. So let's leave the goodies till last, and let's see what happens. Now, typically when we're going M92 short, it's this capacitor right here, this third one along. So let's check this row first. So one probe on ground, which I'm going to use the EMI shield for the CPU and RAM. And we get no short. And we get a short there. Okay, so we've got a short in the middle. And we've also got a short on the typical culprit. And we also have a short here. And as you can see, we get continuity both sides on here. And because these are bypass capacitors, one side is connected to ground, in this case the top and the left hand side. And then we've got a short here. And we've got a short here. And we've got a short here. So M92, definitely bad. And if we take a close look at the right hand capacitor, can you see that? Can you see it? We have discoloration on the capacitor, and the discoloration is underneath the film coating. So you've got a film coating over these caps. As you can see, I can scrape that away, and as we can see, we've got discoloration on the bottom. So, well, that's not actually coming across very well on camera when we're taking the film off, but we have discoloration. So we can look around, well, we can look around those kind of areas for any kind of indications. But we can also look on the capacitors themselves by checking with the multimeter, and as you can see, we do have a short on all three of these. So M92, unless there's a problem with all three of those capacitors, M92 is bad. So let's pop down here, let's check this one, and we also have a short just here as well. So kind of guess that by the discoloration. You can take an educated guess. That one's good, and that one's good. Let's check these ones. I believe it's the bottom for this one, and then oops, and then the bottom for this one. There we go, and those two are fine. So we do have a short on several caps on M92, so that means that we've definitely got an issue with M92. So let's flip the board around quickly, and let's check P13 USB. Now, P13 USB is this rectangular chip here, and this particular chip is responsible for the HDMI output. So when you put the console into docked mode, this chip is what handles display. And sometimes we get an issue with this when we have an issue with the USB-C port, and it's actually about as common as M92. So what I'm going to do is I'm going to test just one capacitor around here, and that's going to be the top capacitor. And the top capacitor is good, so that means we most likely don't have an issue with P13, which is great. That's one less chip that we've got to change. But what I'm going to do next is just check these filters just here. So these are EMI filters, and EMI stands for electromagnetic interference. You find them on most HDMI circuits, and these filter out noise on the data lines for the HDMI circuit before it goes out to the HDMI port, or in this case the USB-C port. Sometimes what can happen is when this chip does go bad, or when we get some sort of a short, it will blow these, and these kind of act like a fuse. And the reason for that is because inside each of these components here are two coils of wire. One coil of wire is from top to bottom, another coil of wire from top to bottom, and what tends to happen is because these are super thin and it's just a coil of wire which is only designed for a low amount of current, you get a power surge and it goes through here, or rather this way, but it goes through here and it blows the EMI filter. So we can check for continuity by popping one probe on top and one probe on bottom, and as you can hear, we've got continuity. What we don't want to hear is continuity from left to right. So if we have continuity from left to right, that means we have a short internally inside the component. And oh, okay, never mind, just a bad connection there. And good, fantastic. So all of those are checking out fine. There's two things we've got to do to this then. First of all, we've got to put a new port on. And second of all, we've got to put a new M92T36 chip on, because that is definitely bad. So what I'll do, I'll actually take the M92T36 chip off first. And I just want to show you that once we take this chip off, it's very likely going to relieve the short on the capacitors around the chip. And the reason for that is because, like I said, it's not the capacitors that are usually bad, it's usually the chip itself. It's very unlikely that you're going to get 4 or 5 different capacitors go bad at the same time. So I'm going to come in with some hot air, 480 degrees Celsius for lead-free solder. And I have just knocked a transistor. Very rare I do that these days. There we go. So there's the chip out, or rather removed. So let me just pop some flux on the board so I can get this transistor back in place. That's just my very unsteady hands. There we go. Okay, so that's resoldered. So that was my bad there. And also the fact that this went out of focus because my mat wanted to expand. So I apologise about that as well. But that's fine. Right, okay, so now that the chip is removed, I'm just going to make sure that there's no bridges on any of the pads around M92, and they do appear fine. So now I can pop one probe on ground again, and I'll use the middle pad. So if you look there, I can get a continuity there because that's a middle pad. That middle pad is ground. And if we pop the other probe on these now, the short is relieved. So no issues now because the component which was causing the short has been removed, and that has basically solved the problem. So all we need to do is just put a new port on, and then we need to put a new M92 on, and we'll be good to go. Okay, so I'm in this area, so I might as well put M92 on first. And one thing you're going to notice is I have not changed the solder from lead-free solder, and that's because there's just absolutely no reason to. So all I'm going to do is just tack this down into place. Whoops, so I've just blew it off. And that's not meant to happen. So let me just knock my airflow down. I should have knocked that down anyway and I forgot. So I'm going to knock my airflow down to 30%. 440 degrees Celsius for reinstallation. So I don't want to put too much heat on the area while I'm reinstalling the chip, and the reason for that is because they're obviously sensitive components and I want to keep as little heat as I possibly can on the area. So 440 degrees Celsius for reinstallation. Once the chip is roughly in place there, I can add some flux. And then I'm going to come back in with the hot air, and this should adjust itself and nudge itself into place. Never mind, because that was pretty much perfectly in place anyway. It did very slightly adjust, but that chip should now be perfectly in line. I don't need to do anything else to that chip. We should end up with perfect joints all around. So let's just clean up. So I'm going to use some isopropyl alcohol and a toothbrush. And just give it a scrub. And then taking a look at the chip there, we can see that this chip is now perfectly aligned. So we can see the two pads on the end, which have got no solder on. That's because they're not in use. And then we can see that every other pad is perfectly lined up, so that's telling me that this chip is indeed soldered. We have no bridges, and it looks dead center on that side. No bridges that side. And no bridges that side. And you can see those pads that are not in use. And then if we go all the way across, we can see the other one. We can see that the rest of the pads are nicely bonded to the chip. So that chip is perfectly soldered. And now we can move on to the port itself. So one thing I am going to do now is I'm going to replace the solder that's here on the port with leaded solder. And the reason I replace the solder on the port is because we want as low of a melting temperature as we possibly can, because we are installing a port which has got plastic on it, and we want to keep it as safe as we possibly can. So let's add some flux. And then we're going to come in with the soldering iron and some fresh leaded solder. And then what I'm going to do is I'm going to pre-apply some solder onto the tip of my iron. So a nice amount of solder there, and then I'm just going to come in and I'm just going to circle around. So the reason I'm going in a circular motion is because I don't want to put too much pressure and too much force on each pad. The Nintendo Switch traces for the USB-C port are very fragile indeed, and all too often I see them damaged. And in fact, the other day I had to replace all but 4 of those traces on one, and I also have another one in the queue with trace damage as well. So certainly not the wisest of ideas to be ripping traces. It's not easy to restore them, it's a very time consuming process, and it's not always successful. Okay, before I install the new port, I do want to try and clean up these ground holes. I did replace the solder with leaded solder, but I just want to try and clean up the ground holes, and the reason for that is because I want to make it as easy as I can to drop a new port in. I can resolder the ground holes afterwards anyway. So just clean up some of the solder, but you do find that not all of the solder will clear out of those holes there, but that's not really too much of an issue because we've got to use heat in the area anyway, so I'm not that concerned. But these ones I do like to have empty. So you're probably wondering why I put solder on those pads then, if I was just going to clean them anyway. That's just to lower the melting temperature for wicking. We don't want to be using too much temperature, like I said, and we don't really want to be using a solder sucker on these pads. The reason being is because, like I said, they're very fragile, the board is very thin, and you're probably going to tear the ground traces away. Now that wouldn't be too much of a big deal, but it means we've got nothing to solder to afterwards. So we want to avoid that wherever possible. Okay, let's clean up and we'll take a look at the port itself, or the pads to the port. So a bit of isopropyl alcohol and a cotton swab now. Just give this a nice clean. Get rid of all of that burnt flux, and we may as well get rid of that liquid damage indicator as well, because that's ruined now because of the flux. Okie doke. Okay, so that's nice and clean. Let's give it a dry. Good. Let's zoom in, take a closer look. Beautiful. Absolutely beautiful. Perfect pads all round. Right, let's flip the board around. And I'm going to attempt to wick away at the pads from the back as well. Just clean out as much as I possibly can, because it's not going to take long for the pads on the other side of the board to heat up, but it would take longer for the ground pads themselves to heat up because it's got a much higher thermal mass. So I'm just going to wick away a little bit of this as well. And it doesn't look like I'm going to get the iron in there. It's not that much of a big deal if I can't. Nah, never mind. Right, okay, I'm not going to get the iron in there, but that's fine. I'll deal with that later. I'll just flood it with leaded later, and it'll sort it right out. Okie doke. So next, I'm going to hang the board over the edge of the table again, and then I'm going to drop a new port on, heating up the area before I do so. Okay, so let's just start with some flux here then. And what I'm going to do is I'm going to hold the port in the tweezers. So I'm just going to get a grip of it just like that. And I'm going to come in with the hot air. And I'm going to heat up the pads. Once I can see that the pads are nice and molten, I'm going to drop the port on, press down, and it should end up soldered nicely. So I've still got my hot air set to 440 degrees Celsius, and my airflow is still set to 30%. Because I've cleaned the bottom ground holes out, I only need to focus on this area here. Okay, so now that the port's roughly in position, I'm just going to come back in with the hot air. I'm going to turn the airflow up now to 50%, and I'm just going to keep moving around in circles until I see this port drop. Press and hold. Okay, and that did start to melt at the last second, so it looks like I might have left it on there a second too long, but that's not really that much of a problem, as long as it's soldered both sides. So let's just take a look here. So let's zoom in. So there is a little bit of the plastic melted. So I'm just going to give the pins the old nudge test, see if they're soldered properly. And they could probably do with a touch up, so probably going to have to change the port if I'm honest, because I'm not going to get in there with an iron. I might have to put another port on. Like I said, I left that a second or two too long. That was completely unintentional. Let me just see if I can break away a little bit of that plastic so I can come in with the port, and I should be okay. I should be okay with that. So what I'm going to do then, I'm going to add some more flux. There we go. And then I'm just going to come in with the soldering iron. I'm just going to use the same tip I've already used. Alright. So it's a little bit difficult to see there, but that should be done. So I'm going to clean up. So let's clean up now then. So again, I'm going to use a toothbrush because I want to get inside all of the little gaps that are on the port, so as I can make sure it's properly cleaned out. Alright, and that should be done. So let's just take a look at these pins again then. Alright, so pin number 12 is not soldered, but that's a ground leg, so I'm not bothered. It's the only one that doesn't appear to be soldered. And it's a ground leg, so if I can't get it to solder, then I'm not fussed. There is a bit of melted plastic there as well. Okay. So they are definitely soldered now. So now all that's left to do is to give it a test. So what I'm going to do, because I'm sick of getting flux on the customer screens, is I'm just going to wipe off my table first, because flux seems to attract to those screens. I'll just get rid of the flux off there. And there we go. Alright. So there's the new port installed. And I do still need to solder these bottom legs, but I do want to just test it first. Actually, I may as well solder them now, to be honest. It'll only take a second, because that way when this gets put back together, as long as it works, it doesn't need to come back apart again. So let's just solder them now. Let's stop being lazy. One thing you'll know about me is I am a lazy technician. Oh, okay. So that's that. Whoops, stuck to my hand there. Never mind. Let's just clean up. What I also want to do is just try and clean out the inside of the port as well, because we do tend to get flux in there. There we go. That will be more than enough. And the front I've already cleaned, so we should be good. So what I'm going to do is I'm going to assemble it enough for testing. And if it works, then I'll carry on assembling it. And then we should be good to go. We should be good to go. So let's just route the cables so as they're not in the way when it does come to reassembly. So one nightmare cable is always this speaker cable. Always likes to get stuck under the board. And also the backlight ribbon as well. That always gets stuck. And the Wi-Fi cable as well. There we go. Okay. So that's locked down. So I'm not going to screw anything down, but I will pop the ribbons in. Okay. Let me get my good tweezers here. Okie doke. Right, so one thing I am going to do just for the sake of testing is I'm going to put the screws inside the USB-C port, and the reason for that is because I don't want to risk breaking the USB-C port again, and if I put this into the dock in a minute I'm going to break the port. So one thing I tend to do is drop screws. So yeah, that's a thing. Yeah, but never mind. So I'll pop the screws in the USB-C port here. Just make sure that the port itself is secured to the chassis so it doesn't damage anything. And also I'm going to pop the touchscreen on. But first of all, actually, I need to pop a screw in here. So the reason I'm putting certain screws in is because if it does work, then I haven't got to take it all back apart to put these screws in. Because the screws that I'm going to be installing are all hidden when it's fully reassembled. So we have to try our best to get the correct screws in properly first. Also, the fan as well. There is one screw in the fan which needs to go in, because that'll be covered by the touchscreen connector, or rather the touchscreen module. So this screw here will get covered up by the touchscreen and headphone jack modules. So just make sure those are in. We may as well screw all of the fan screws in though. It's only 3 of them. There we go. And then, like I said, get the touchscreen module in. So what I want to do is I want to give it a full test, but like I said, I don't want to reconnect everything, or rather screw everything down, because then I've got to waste another 5 minutes disassembling everything. But I do need to make sure it's secure for the testing process. And this connector is the bane of my existence. I absolutely hate that connector It's so annoying. Okay. And now what I want to do is I just want to test it with a non-good battery. So I'm going to use the same battery I've just used, because I know that battery has got some life in it. So what I want to do is I want to just see if that error code is gone. And the reason for that is because if the error code is gone, then we know we've fixed at least one of the issues. So we get the Nintendo logo there. And that error code is gone. That's absolutely brilliant. Touchscreen works. And we've got 17% of charge. So let's grab a charger and we'll test that. So the reason I'm doing this now is because this is going to take about 20 minutes to charge up. So I don't really want to be wasting a load of time. And okay, so software might be a bit slow. So it does say it's charging. So I'm going to leave it till it basically increases in percentage, because there is one thing that you do need to look out for on these, and that is backfeed. So even though it's never supposed to happen, what tends to happen sometimes is the charger will say it's charging, but it's actually not. There we go, that increased to 17%. I'm going to wait for it to get to 18 anyway. What will happen sometimes is the console will say it's charging because it's recognised that the charger's plugged in. So there's a couple of pins on there called USB-C detect, and that basically detects when the charger's been plugged in and tells the console that it's charging. It does all its signalling and things like that, tells the battery management IC BQ24193 to turn on, and so on and so forth. But what's really happening in reality is the power is backfeeding into the charger itself, and the battery is charging the charger, if that makes sense. It's kind of like with cheaper circuit designs when you get really cheap knockoff brands, where the battery will backfeed and light up some sort of a light on a charger or something like that. And we don't want that to happen, obviously, because then it's going to drain the battery, it's going to charge the charger, and the power's going nowhere. So we always have to make sure that it's actually charging. There is a known issue on, or at least it's known to me, there is a known issue sometimes where we will plug the charger in, it won't give any response at all, and then we'll turn the screen off, turn it back on, and then it'll show that it's charging. And that's what I just had to do with that one. So it's kind of annoying when that happens, because it makes us think that it's not actually charging, but it's just one of them things. So I'm going to wait for this to get to 18%. Hopefully it does. Hopefully it doesn't go back down to 16. And then I'll flip the charger around. There we go. There's 18%. So now I'll flip the charger around, and just like that. And it's charging that side. So now I'm going to wait for that to get to 19% and make sure that it's not backfeeding through this way. So basically the way the USB-C port is designed is obviously there are two rows of pins, and that's what allows us to be able to charge this both ways on the charger. So no matter which way you flip the USB-C port around. So obviously because one of these rows is on the bottom, it's hidden. So you can take a look there, and you can see that one of those rows of pins are actually hidden, and that stops us being able to see those pins when we're soldering a new port. So we have to just hope and pray. It's kind of like hit and hope with a round of golf. We just hit the ball and hope it goes in the hole. Same with this, we hit this and we hope it actually solders properly. So we need to make sure that it charges both ways, and if it charges both ways, then it's probably going to dock, but I can't know for sure if it's going to dock until I actually attempt to dock it. So I will attempt to dock it, but I need to charge up the customer's battery first, because I can't put it in a dock like this. So because I haven't got a USB-C cable that's capable of being run from the dock and as an extension, it's kind of difficult. So I've got to actually charge the customer's device up to be able to test it on the dock. There we go, 19%. So that's probably going to charge. It's probably going to dock. It's probably going to be fine. So what I'm going to do now is I'm going to leave this to charge for 10 to 15 minutes, however long it takes, however long it needs, and hopefully passes the rest of the tests. So for you it'll be a moment, for me it'll be a cup of coffee. So I'll be back in a minute. Right, okay ladies and gents, so this is now turning on, and as you can see it's saying 1%, so I'm going to give it a quick test while I'm waiting for a little bit of power to come back into it, and then we can see what's going on. Fingers crossed everything is working fine. Okay, so DC supervillains, that's working absolutely fine. Good. So let's pop a Joy-Con on here then, and that syncs. One thing I noticed is the fan is spinning, which means that the Joy-Cons will also charge as well because the circuit is linked. And as you can see, it does charge Joy-Cons. Absolutely fantastic. So let's take another Joy-Con then. So let me just find a test one. Just here. So these are just test Joy-Cons. They don't work very well, but they do work for testing. That works fine. Excellent. So that seems to be working. So let's test the internet. Make sure we do get internet connectivity. And as you can see by the Wi-Fi password, there is a subliminal message there. If you're new to the channel, you should really follow that advice. It's very important. Let's press OK. Boop, boop. There we go. Okie doke. Right, test internet connection. Awesome. So that's working fine. So let's go to controllers and sensors. Test input. Test touchscreen. Excellent. Touchscreen works. That's getting rather warm now, so I'm going to start putting this back together. So I'm going to start by putting some fresh thermal paste on. And then let's clean off the rest of the heatsink here. Okay. Right, so we may as well put this back together while we're leaving it to charge. I've got a good feeling that this is going to dock absolutely fine. So we may as well just put it back together now. And then I'll test the dock, and that's pretty much the last thing I need to do. Fingers crossed it does actually work on the dock. I'll be rather upset if I put it back together and I have to take it back apart again, just to put a new port on. One thing I should point out is when you're putting this screw back in where the speaker cable is, do be careful not to short out the speaker cable by screwing through it. It might be best to unplug it and to plug it back in once you've screwed it down, because it will throw out an error code if you've got a short on that speaker wire. Just a little bit of advice based on my experience. I've made that mistake once. I fixed a Nintendo Switch with a similar problem, and basically put it all back together. It was all working fine during testing. Put it all back together to find an error code, and it turned out I'd shorted this wire out, so I had to replace that speaker, and that fixed the error. So yeah, just a little bit of advice there, just to be careful of that one. So I'm basically just putting this back together now, just giving it a little bit of time to gather up a bit of charge so I can actually put it on the dock. I could have done this while I was waiting for it to turn on, but coffee called. The coffee was calling me. I've put that back on there because I want to be cheeky and charge my Joy-Cons on this device. I could charge them on my own, but meh, I'll just charge them on here while I'm charging the console up. This console will get a full charge before it goes out to the customer. And all that's doing is just telling me that the Joy-Cons have got low batteries. That's what that beeping is. Which is pretty common because they don't very often get a charge. And we're on 9% right now. But these do get a full charge before they go back to the customer anyway. Another little tip, the screws that go in the bottom and the top of the case, the black screws, they are non-magnetic, so don't get them mixed up with the ones that go in the board, because the ones that go in the board, they are the same colour, they look the same, but they are magnetic, whereas these ones are non-magnetic, which is why I'm not attempting to grab them with the screwdriver, because the screwdriver is not going to grab them. As you can see, non-magnetic, so just be wary of that. There's obviously some sort of a reason why Nintendo chose to do it like that. I'm not sure why, but there's got to be a reason. Otherwise they would have just used the same screws to save on cost. They probably are pretty much the same screws, but just non-magnetised. So those ones there, as you can see, they do pick up with the screwdriver. Okay, and the console's back together. Console will enter sleep mode. No, go away. Just pressing buttons there while I'm messing around. Alright, let's just check the charging functionality on both sides again. So we know it's charging that side. And is it going to be a pain in the backside again? Yes. Nothing new there. Tends to do that sometimes. Not sure why, it just does. Right, so what I'm going to do now then, I'm going to hook up the dock. So I've got myself an official Nintendo Switch dock here. You wouldn't believe this thing is brand new, but it is. It's absolutely filthy. But I'm going to hook up the dock to the capture card. And we'll see what happens when we try and dock it. I'm going to be very upset if I end up having to take it back apart again. But never mind. Okay. So HDMI cable there. We get a green light on the dock, which is good news, because that means it is picking up. And there we go, fantastic. So that is docking absolutely fine. The only thing left to test now is wireless controllers. So let's just check those. Yeah, there we go. Wireless controllers are working fine. So that's absolutely great news. It's docking, it's charging, everything's working. We no longer get the error code, and this job is complete. So just to summarise then, so this console was originally sent in because it had a damaged USB-C port, and it also had a serious error when it was tested with a charged battery. The serious error was 2001-0001, which is a hardware related error code, and I determined from experience that is always related to M92T36, which is this little IC just here. And M92T36 is a power management IC for the Nintendo Switch, but by replacing the USB-C port and by replacing M92T36, we've got rid of the error code, we've cleared all the shorts, and this console can live happy once again. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. I will always do my best to answer them. And if you want to see more repair videos where I repair mainly consoles, but sometimes other things too, be sure to hit that subscribe button and turn on the bell notifications so that you're notified every time that I upload. If you do find my content useful and you want to support the channel, I do also have channel memberships for as little as £1.99 per month. And you can become a channel member and support the channel, and all channel members get early access to my videos. But that's going to be it for this video. Thank you very much for watching, and until next time, see you later. Bye for now.